So the maximum modulus theorem says that if you've got a function f of z which is analytic inside some simple closed curve gamma, then the maximum value of mod f of z in that region occurs on the boundary of the region. So to show this, I mean, this in a way is sort of easy to see if we think about Gauss's mean value theorem. Because Gauss's mean value theorem, let's write it out again, says that if you've got some circle, then the mean value of the value of f at the centre of the circle is equal to the mean value of the points surrounding it. So if this is not a constant function, if you've got some circle with centre z0 and this is the mean value, and it's not, that means there's got to be some values which are larger than this value here and some values which are smaller, unless this is all constant on the circle. So that means that z0 can't possibly be the largest value on the circle. Okay, so you can put z0 anywhere inside. Inside, if the circle is of finite radius r, then it's not going to be on the boundary. So that's a sort of hand-wavy argument about why this is true, why the maximum value of f has to be on the boundary. But if we want to do it more properly, then we apply the triangle inequality test. So remember the triangle inequality says that the modulus of z1 plus z2 must be less than the modulus of the sum of the moduli. Okay, so the length of this line here has got to be less than or equal to the sum of this. So when you're doing an integral, this plays the role of the final result. So f of z0 is an integral, really is just a sum of lots of little bits. So this has to be less than or equal to 1 over 2 pi, and then the things you're summing, modulus of the things you're summing. So we're okay, as I've drawn, the z0 and r talking about a circle inside the region. Okay, so suppose we sort of prove this by contradiction. So suppose that there is a point somewhere here where f on the interior where f of z has its maximum. Well, that would imply that all of these points, if f of z has a maximum, then and all of these points around here would have to be of magnitude less than this one. But that's contradicted by this statement here. So it can't possibly be true. So basically, the maximum value has to be on the boundary.